Good morning, all of you. So today we are going to start with the subject known as data structures, and today we are going to see the introductory part of it. So let's move ahead. Let's go about to the brief of this subject. So myself, Disha Roshan Bhakta, Assistant Professor, Department of Information Technology, Bansangas, SMCT College of Science, Commerce and Management Studies, is going to make you walk through to the subject data structures. Today, we are starting with the very first session of data structures, that is nothing but the introductory part. Now, what we are going to learn today, okay, so these are the objectives of today's session. Our objectives would be, we have to know about what is data and information. We have to know about the concept of data types. We have to know about what are data structures. Of course, our whole subject is about data structures only. But yes, today in a very brief note, we will see and understand what exactly data structures means. And then we are going to see the classification of data structures also. Fine. So let's move ahead. So we'll start with a very, layman term, a term which people are aware about since many years ago, that is data, right? So I believe that everything what we see in the world today, or maybe everything which was there previously, and if I want to, know about something, I always prefer, I want data regarding it, okay? So if anything is there, we simply have a convention in our mind to say data. But yeah, so we already are aware about what is data, but let's today see in a bit technical form what this data means. Okay, so let's start. Data refers to value or simply set of values that are raw and unorganized. Okay, so what we are trying to tell is that data refers to maybe value or set of values, okay, that are raw and unorganized, which means, let's say, just giving you an example, if I want to know that how many number of trees are there in Powai. So maybe let's say someone will tell that there are 500 trees in Powai, or let's say somebody will tell that there are 600 trees in Powai. That's it. So this is data, 600 trees. That's it. So what is it? It's value or maybe set of values. Okay. And it is raw. Okay. It's just a number. It says 600. That's it. Nothing more. Okay. So data may be simple, random, and useless until it is organized. Okay, so data is going to be very simple, random in the sense, it can have different numbers into it, but it's not of use until we are going to organize that data. Now, data is valuable raw material which can be in different forms, such as numbers, words, and alphabets. So maybe let's say I tell, as I just told you, 600 trees. Okay. So yes, it is very important for me, first of all, to know that raw data first. Okay. I'll tell you later on why it is important. But yes, so it's not that it's of no use. It is valuable, but it's raw. Okay. And it could be numbers, as I told you, let's say 600 trees. Alphabets, let's say maybe I talk about that, tell me the number of or tell me the name of the students, okay, in this specified ABC class. Then I may get a list of students. Okay, so that's again a data for me. Fine. So again, I'll repeat all of you the definition. The definition of data tells that it is nothing but value or set of values which is raw and unorganized, and it may be very simple and random, but yes, it is of not much use until we organize it. It can be in different forms such as numbers, words, alphabets, etc. Fine. Let's move ahead. Now, after data, okay, yes, I'm using the word after data, which means information will have its existence only and only when you have data available with you. Okay. So what is information? Data, when processed, organized and presented in a meaningful context becomes information. So whenever you have your data and you have organized it, and and you have presented it in a meaningful form, maybe your presentation could be in form of maybe graphs, or maybe charts, or maybe some kind of analysis, etc. But yes, when you start presenting your data after analyzing it, it becomes information. Now these information plays vital role in decision making, which is obtained from data. These information which we have got from data, but yes, it will help me to make some decisions. So we took an example that how many trees are there in Powai. Okay, so we got data that there are 600 trees. Now, let's say if I process and organize this data and present in a meaningful form. So, maybe it may happen, I can get a rough analysis of that. There are 100 trees of fruits, maybe 200 trees of flowers, maybe 100 trees which are there in existence, but they are almost drained down because, nobody has watered them or something like that. So at the end, I may get an information and it will help me in making some decisions. The decisions could be something like, that these are the trees which we have to take care of more. These are the trees which are yielding good stuff to us. So we should go one step further about it, etc., etc. Okay. Same way, let's say I have just data about the name of the students, and maybe some other information, maybe some other characteristics of student. But yes, when I make information from it, I can come to know, okay, these, let's say, these students are facing difficulty in these area. These students are good in this area. These students are want to do something more in this area, etc., etc. So what information is, when you have data and you process the data and then you organize the data, then you get the information from it. There could be hundreds and hundreds of examples where you can talk about data and information. And as I told you, yes, of course, first of all, there has to be data, and from that data, information will get generated. Fine. So this is about data and information. So now let's look differentiation between data and information. Of course, there will not be just clear cut differentiation, because you have to understand that if the availability of data is there, then only information is going to be there. Okay, so now what it is, let's see the first point. Data is unprocessed facts and figures. Okay, so you have figures in data, but yes, it is not processed. Okay, it is just raw, it is just random. And what is information? So when you are going to process these facts and figures, you are going to generate information. Data does not depend on information. Okay, yes, this is very important. Data have no dependency on information. Okay, you can start collecting the data, you can start generating the data. That can happen again and again and again. Yes, but information is something which is going to be dependent on data. Okay, so if data is there, then only information can be there. Data is not specific, information is specific. Okay, so data, it is something which is not specific. Okay, it will not talk you about the categories, or it will not talk you about any analysis. But yes, information is very specific. It will tell you, yes, these many percentage of these things exist. Then in an area of Powai, let's say you have 30% of people who belong to age group of 65 and more. Okay, data will just tell you these are the people, these are the ages. That's it. There are, let's say, 5,000 people, and then their age will be listed. That's it. So that is data. It is not specific. Okay, you may have a data about a person of 66 years old. Below that, you may have a data maybe of a child who is just 3 years old. After that, you have a data of a person again who is 20 years old. So that will be data. But information, what information will tell you? It will strictly categorically do bifurcation in such a way that, okay, these many people, okay, or these are the names of people who are belonging to an age group of 20 to 30. And these many people are someone who are belonging to an age group of 45 to 60. Then these many children are there who belong to an age group of 2 to 10 years old, something like that. So that is information, okay? That is information for me. So information is always specific. Data may not carry any meaning, okay? It can be, as I told you, 600 trees, that's it, okay? It is not having any meaning as such, okay? It's just a number, 600, that's it. Information must carry a logical meaning. So if I'm going to process that data, then the information of that data should be, it should tell me, okay, what exactly those 600 trees means, okay? How I'm going to understand it, how I'm going to interpret it, okay? So that is information. And of course, when I see information, at times, whenever you collect data, you don't physically see, let's say the data that is collected 600 trees, you never have went outside and see those 600 trees, okay? So if you are going to just say 600, the person will never get an idea what exactly you are talking about, okay? But yes, if I do a category, if I put it as an information, okay, if I give some logical meaning, okay, that, oh, in this 600 trees I'm talking that 100 trees belong to, let's say, mangoes. And yes, if I do a very good graphical interpretation of it and show it, yeah, that will sound some logical meaning to me. So information will always have a logical meaning, okay? And last but not the least, data behaves like a raw material. Information is a product from data. Of course, we have to understand that to derive the information, we should have the data first with us. So that was about data and information. Let's go to the points again. Data is unprocessed facts and figures. Information is processed data. Data does not depend on information. Information does depend on data. Data is not specific. Information is specific. Data may not carry any meaning. Information must carry a logical meaning. And data behaves like a raw material, whereas information is going to be a product from data. Fine, let's go ahead. So now, as we have just seen the concept of data, so this concept of data and information, it is not just it's not just a technical concept, okay? If you are going to study maybe any subject, it's not just a concept of data structures, okay? If you're going to learn about anything, okay, this data and information will always be a part of it. So this is very generic, okay? We should always be aware about what is data and information. That's something very generic. Now we are coming to a technical aspect on what we use, okay, on what we use when when we have to program, okay, because in each and every of our program also these data plays an important role. And yes, information also plays an important role into it, okay? Yes, but we are going to start with data, okay, because we are much used to it, and maybe since long amount of time we have already used it, okay? So when we want to use this data into any of our language, now when we say language, of course we all are familiar with that, we are trying to tell that programming language. So what we do is, so here comes the concept of what we call it as data types, okay? So, what exactly is it's a data type? Okay, so let's first of all understand in a layman term. Okay, so let's say we took an example that I want to note down that how many persons are there and what is the age of that person. Okay, fine. So when I'm going to write the name of that person, how it is going to be? Let's say A B C X Y Z. Okay, P Q R. So the name of the person is always going to be what I say, maybe, a collection of alphabets or words, or what I appropriately call it a string. And when I want to denote the age of the person, okay, what I write, 15, 20, 65. Okay, so what is this? Numbers, right? This is nothing but numbers, okay? So we are normally aware about that when we talk about data, okay, we can visually understand, okay, throughout our whole educational process we understood that, okay, this is alphabets, or this is words, or this is numbers, or something like that, okay. And we have that understanding because we are well aware about the languages, you know, maybe our English language or maybe our regional languages or something like that. But now we have to understand that these concept of data or the type of the data we want to feed into a programming language. Okay. Now this is language, okay, which is not an English language, which will understand that when you say ABC, you know, it will have a spark in the mind and understand, okay, oh, this means string. Okay. No, so therefore, every programming language have came up with their, you know, what we call list or collection of data types. So what exactly do we mean by data type when we want to talk about a programming language? Okay, let's understand. Data type is an attribute or characteristic of data which tells the compiler or interpreter on how the programmer wants to use the data. Okay, so let's say, giving you a very simple example, if I want to represent age, okay, so what is age? It is going to hold data. Now what is the characteristic of age? This, the characteristic of age is that it will always hold numbers. Okay, now the programmer, okay, who is you know telling, who is telling that he or she wants to use age, he in his mind or she is in his mind is aware that, okay, when I talk about age, I want to feed numbers into it. Okay, but how will this information go to a programming language, or how these information will go to a compiler or an interpreter? So for that, the programming language will give us data type. So whenever I mention age, before that I mention the data type of the age. Okay, that what should be the data type, and what is the data type? It's a type of the date. It's the type of the data which it's going to hold. Okay, so in my case, as I'm aware about that it's numbers, so maybe according to the programming language I have to specify some data type over here which signifies or which tells that age is a number. That's it. Okay, let's go to the definition. Data type is an attribute or a characteristic of data which tells the compiler or interpreter on how the programmer wants to use the data. Okay, data types may be different for different programming languages. Okay, more or less in many programming languages they hold the same meaning, but yes, there could be certain variations as we go ahead through the programming languages. Data types also define what kind of operations can be performed on the data. Yes, so this is also very important. First of all, data type will tell you what kind of data is going to be held in in let's say the type in let's say the data that you have specified. Okay, what type it is going to hold. Also, it will specify what operations are possible. So we have just taken a very normal example. So if let's say I have two integer values, or maybe I can see if I have just two numerical values, then it will tell me that yes, if you have two numerical values, the operations like addition, subtraction, multiplication, division are possible. Whereas if those values are string, okay, then the operations like concatenated, comparison, copy are possible. So the operations will also be defined once we define our data type. Okay, fine. So that's about data type. Let's go ahead. Now, data types are broadly classified into two categories. The first category is primitive data type, and the next category is abstract data type. Now what are primitive data types? Okay, so let's say if you are going to walk through any programming language, for example, here we are just having a discussion about in an example C language, and if there is a data type which is already provided into that language. Okay, we call those data types as primitive data types, or maybe predefined data types. Why predefined? Because they are already fed into the programming language. Or we also call them as basic data types. Okay, so primitive data types are also known as predefined or basic data types. These data types may be different for different programming languages. And if we have taken an example of, let's say, C language, the primitive data types for storing integer values in C language are, let's say, int, long int, short int, and maybe for storing the real values, we have primitive data types like float, double, long double, etc. So let's say if I want to represent age in C language, I simply have to write int and age, that's it. And I am using over here my primitive data type, or my, let's say, basic data type, which is already given to me by C language. Okay, so that's about primitive data type. I think primitive data types, we all are aware much about it, because yes, we have used it n number of times till now. Now let's go ahead. Abstract data type. Okay, so now this is a concept which is one level more up, let's say, than normal primitive data types. But yes, because we are already aware about what we call it as object-oriented programming, we could understand this concept also nicely. What are abstract data types? So abstract data types, as the word says, it contains two important features. So of course, please understand, when I tell abstract data types, they are also data types, which means they are also going to tell me the type of the data it is going to hold. But yes, with some abstraction on it. Now, what do we mean by abstraction? Okay, so now abstract or abstraction refers to the act of representing essential features without including the details. Okay, so now what exactly is going to happen when you talk about abstract data types, that it will have data type, also it will define all the operations which you can perform on the data type. Okay, but when the user is using the data type, okay, the user will not understand that how these operations are performed. Of course those codes will be written by programmer, but on the user end, it will become very easy. He will not be able to understand that how they are performed. So what we do is we tell the user that you use it, you perform it. Okay, but we are not telling that the details about how it is performed or like that. So abstract data types basically contains two important things: encapsulation, okay, that is providing data and operations together. Remember, this is most important thing. Okay, we are trying to tell that we are going to provide data as well as operations together. So one basic difference that you can see between the primitive data types and the abstract data types over here is that when I'm going to make an abstract data type, I'm also going to provide all the operations of that data type over there. And what is abstraction? Hiding the details of implementation. So I provide all the operations, but maybe how they are implemented, I'm going to hide them. Okay, as a programmer, I'm going to hide them from the user. Now, some examples of abstract data types are array. This is first abstract data type, or maybe later you will also come to know that these abstract data type are nothing but data structures also. Okay, so array, we all are already aware about what array is. Of course, we are going to see about array in detail also into this into this subject later on. The next abstract data type is stack. Okay, what is stack, what is queue? We are going to walk through all of these concepts in coming days. Okay, so as of now, we have to understand that when we talk about abstract data type, we are telling that yes, it is a data type, but it has certain more characteristics than data type. And what are those characteristics? Okay, so over here you have a feature wherein you can have operations all together with the data, and you have a feature wherein whatever operations you have implemented, the user is not aware of. Basically what we do is we hide the details on how we implemented those operations. Okay, so this is about abstract data type. Let me go back again. we started with the concept of data types, okay, and then we saw that there are two basically broad categories of data types. One is primitive data type, okay, the ones which are already given by the programming language, and another is abstract data type. Yes, when we talk about abstract data type, it is a data type which we as a programmer have to make, okay, whereas primitive data type is something which is already given by the language, so we can just start using it. But yes, when we talk about abstract data type, it is something that we have to make, okay, of course, using the features of the programming language, using the primitive data types, etc, etc. Okay, so maybe we are already aware about what class is. Okay, class is also data type. Yes, so we can tell that okay, class may belong to an abstract data type, because if we talk about class, then yes, we have data as well as operations which we can perform on that data into it. Okay, fine. So that was about abstract data type. So now let's talk about the thing on which the whole subject relies: data structures. So till now we saw what is data, till now we saw what is information, then we saw let's say what are the data types, then we saw primitive data type, and then abstract data type. What is data structures? Okay, so the first word, data, I think we are all aware about what exactly data is. What we are telling is data structures. Okay, so let's say we want to maybe store data into some structured format. Okay, now where exactly we are talking to store this data? Okay, uh, so yes, because we are talking about a programming language, yes, because we are talking about computer systems, we want to store this data into what we call as computer's memory. Okay, so what is data structure? It is a way of storing data in computer's memory so that it can be used efficiently. Okay, so we want to store data, what we are talking about, into computer's memory. A data structure is a logical or a mathematical model of organization of data. Okay, so with the help of data structure, I can build a logical model on how I'm going to organize or put my data into the computer's memory. Now how it will help me? Okay, so rather than just randomly putting my data into the computer's memory, if I put that data into a data structure, then it is surely going to help me to, let's say, perform all the operations on my data very efficiently, maybe using less time, less memory, and little resource. When we say resource, we are talking about the, let's say, the processing capacity of our machine. So if I'm going to organize my data properly into a data structure, all the operations which I can perform on this data. Now, what sort of different operations which we can perform on this data, uh, we'll see into our consecutive lectures. But yes, if my data structure is made properly, then I can perform all the operations on my data with less time, less memory, and using little processing power. Okay, so again, what is data structure? Basically, it's a model, or it's a way which helps me to store my data into my computer's memory. And if I design my data structure well, then yes, I can perform all the operations on my data efficiently. Okay, now these data structures are classified into basically several ways. These ways are linear and non-linear data structure, static and dynamic data structure, homogeneous and non-homogeneous data structure. Okay, so this concept is very easy, and you will be quickly able to understand it. Okay, so let's move ahead. So the first type is linear and non-linear data structure. So let's say if I say in my data structure, all the elements, or maybe say all my data, is arranged in linear form. What do I mean by this? Let's say if I have, in my data structure, I have 5 data. Okay, and if I have arranged my data, of course, in computer memory in such a way that there is first data, and after that there is next data, then after that there is next data. Okay, there is next data, then next data, then next data, then yes, I call that data structure as linear data structure, wherein all my data into my data structure are allocated one after the another. When I say non-linear data structure, okay, so in this data structure also, my data elements will be there, but they will be non-linear form, which means there could be one data, and not necessarily that the next data should be into the consecutive location. It can be somewhere else also, okay. So these kind of data structure is known as non-linear data structure. The examples of linear data structures are array, queue, stack, and the examples of non-linear data structures are tree, graph. Students, these are those data structures which we have to see throughout into our subject in detail. Okay, so you just get familiar with names and what they hold, what exactly they will be. We are going to see all about it. Okay, again, the first category is linear and non-linear. In linear, the elements are stored one after the another. In non-linear, the elements can be anywhere into the location. Okay, let's go ahead. Okay, now the next kind of the data structure is static and dynamic data structure. So what is static data structure? So let's say when you make static data structure, whatever memory you have allocated to this data structure, it is going to be the same. Now afterwards you cannot increase or decrease the memory at runtime. Okay, I'll take an example. So I think we all know that we have made an array, okay, and I simply read, let's say int arr 10, okay, which means I want to make an array of 10 integers. Now when I talk 10 integers, and if I talk about C or C++ language, one element or one data is going to take 2 bytes. So here what I have done, when I have written int arr10, I have told that I want to reserve 20 bytes into my memory for my array or for my this data structure. Now later on I realized that no, I am not going to make use of 10 elements. I'm just going to make use of 5 elements. Okay. So what later on I realized, I'm not going to make use of 10 elements. I'm going to make use of 5 elements. But no, because it is a static data structure, it is not going to allow you to decrease your memory now. It is fixed. Whether you use it, whether you don't use it, it is going to remain the same. Another story, let's say you have reserved a space of 10 elements, and then suddenly you realize no, some more details is going to come, so I might have 20. Again, sorry, you do not have space because it's a static data structure. It will be just using the memory, or it has just allocated the memory that you have defined. No increase or decrease is possible at the runtime. Fine. Now, on contradict to this, okay, you have dynamic data structures. So in dynamic data structures, there is no fixed memory. You always have an opportunity to increase or decrease the memory at runtime. Now, when we'll see this data structure, okay, so when we'll see a linked list, okay, which is a major part of our subject also, we will understand how dynamic data structures work like. But as of now, it's important for us to just understand, okay, that if I have a dynamic data structure, I can increase or decrease the memory at runtime. Okay, fine. And the last kind of data structures are homogeneous and non-homogeneous. I think, yeah, we are familiar with this word. When we say homogeneous, whatever data I store in this data structure will be of same type, which means, if I want to store, if I want to store numbers, then I can just store numbers only. There is no provision wherein I can store numbers also and strings also. Okay. So that is homogeneous data structure, wherein all the data that you are going to store will be of the similar type. Okay. And non-homogeneous data structure. So here you have provision to store the data of maybe multiple types. So maybe some part of the data could be, let's say, integers. Some part of the data, let's say, could be float. Some part of the data could be strings, or can be a collection of everything. So that is the provision in non-homogeneous data structures. Again, the example of homogeneous data structure is array, and the example of non-homogeneous data structure is linked list. Okay, let's go back. Okay, so we started with data structures. Again, students, data structure is nothing but a way of storing data. But where? Into my computer memory. And when I make a data structure, I'm going to do a logical organization of this data, and it will be helpful for me to perform all the operations on the data easily and of course efficiently also. Okay. Data structures are being classified into several ways. The first way, which we have seen, was linear and non-linear. In linear, the elements were arranged in linear sequence, okay, one after the another. In non-linear, not necessarily they have to be one after the another. Static, whatever data structures are static data structures, they will have fixed memory location. Even if the memory requirements change, we cannot do anything at the runtime. Whereas in dynamic data structures, there is nothing like fixed memory. You have an opportunity to increase the decrease or memory at the runtime. And then you have homogeneous and non-homogeneous data structures. Okay, so when we talk about homogeneous data structures, whatever data we are going to feed into these homogeneous data structures will be all of the similar type. Okay, whereas when we talk about non-homogeneous data structures, it can hold data of different types. Okay, fine. So let's again do a quick revision of what we understood today. We understood about the concept of data and information. Data is raw, it is not organized, it is not specific, whereas information is a product from data, which is processed from data, organized from data. Okay, data information is specific, it will give me certain logical meaning. Okay,